All right, that's pretty good, right? Now, as we advance this technology further, you're going to be able to create nuanced worlds to explore and share experiences with others with just your voice. But there are a lot of challenges that we still need to solve to get there. One is developing true multimodal AI. A lot of the early AI work has been focused on text. When you have a clearly defined syntax, a finite set of input words, and a lot of easily available training data, predicting how a sentence might end can be relatively straightforward. But if you only have 10 or 20% of an image, predicting what the complete image will show is a lot more difficult. And figuring out what scene in a video will come next is another step change in complexity. So now imagine going beyond video to fully immersive experiences. What will it take for AI to accurately interpret and predict the kind of interactions that will happen in the metaverse, where people are moving between physical and virtual spaces and creating all kinds of new worlds? The main way that we have approached this is by working on self-supervised learning. Now, before SSL, most AI systems were trained with supervised learning. That means that you feed them lots of labeled data, say 100,000 images of cats, and explicitly tell them this is a cat, this isn't a cat, until they recognize some patterns. But Jan LeCun, our chief AI scientist, believed that this wasn't going to be enough to produce systems that can really understand the world. So we made a big bet on self-supervised learning. And the idea here is that you don't teach the AI any specific concepts. You just give it raw data and ask it to predict the missing parts, and it will learn abstract representations along the way. And this actually seems closer to how the brain learns. For example, you don't need to show a kid thousands of pictures of a cat for them to understand what a cat is. Now, this has become the primary method of training AI to understand natural text, and it is now achieving state-of-the-art results for images, speech, and other types of data too. In fact, self-supervised learning now outperforms many other existing methods for images and video, even models that rely on millions of labels, which is a huge step forward. And while self-supervised learning is still developing, we think that it's going to be an important tool for the metaverse, because the complexity and diversity of the environments that people will experience in AR and VR will be too great to be captured with labeled datasets. Traditional computer vision techniques also aren't going to be enough to support that real sense of presence and interaction that will define the metaverse. So to help advance the state of the art in systems that can see and understand the world like we do, we recently brought together a global consortium of 13 universities and labs to work on Ego 4D, the largest ever egocentric dataset with thousands of hours of first-person video and benchmark tasks that everyone can use to research and build. So if you're working in this space, I highly encourage you to check this out. Now, the big goal here is to build a universal model that can incorporate knowledge across all modalities: text, speech, movement, position, body language, all the information that is captured through rich sensors. This will enable a vast scale of predictions, decisions, and generation, the fundamental processes of how AI systems learn, as well as whole new architectures, training methods, and algorithms that can learn from a vast and diverse range of different inputs. Now, this is a major challenge and one of the critical steps on the path towards true AI. But before we get there, AI can help us solve an even more fundamental problem.